General solution of a trig equation, part 2. We're going to solve a sine bt equals c. And we have similar formulas here. If c is greater than 0, we have a quadrant 1, quadrant 2 solution for the sine. Sine is positive up on top. And we have reference angle plus 2 pi n divided by b, or pi minus reference angle. That brings us back into the second quadrant, plus 2 pi n. Divide everything by b, which is that coefficient there. And c is less than 0, we're in quadrant 3 or quadrant 4, and we have similar formulas you can follow. These numbers were left over from before. I forgot to erase those, so we'll get rid of those. Those are unnecessarily there. We're going to solve 3 sine 4t equals 1, a equals 3, b equals 4, c equals 1. C equals 1 is greater than 0. We're going to use formula 1, so we're right here. And we're going to write out 2 t formulas. That'll give us the 2 parts of the solution. Well, first of all, t equals, we need inverse sine c over a, which in this case is 1/3 divided by b plus 2 pi over b times n. We're right here in the formula. And t equals right here, pi over b, pi over 4, minus inverse sine 1/3. You can put the absolute values in if you really want, but c over a is positive in this case, so you really don't need that. Over 4 plus 2 pi over 4n. Now, like before, you can calculate this. Make sure your calculator is in the radian mode. And this coefficient ends up being 0.08495. Then pi over 4, 3.14159 divided by 4, 0.7 something. Minus that gives you this actually, 0.7004. So that should be the same as that. And then, of course, that's the same thing, 1.5708. So this gives you the 2 parameterized solutions. The rest, what I left out, is just calculator exercises. So now, let's suppose we want the first 4 solutions. Well, we're going to let n equal 0. And we're going to plug 0 in right here. Of course, it zeroes these 2 terms out. You just have this number and this number. And so you have T1 is 0.08495 plus 1.5708 times 0. And you just end up with 0.0849. We'll write that down here so you can see the I guess there's a 5 here. And then we'll write T2 equals, plug 0 in here, 0.7004 plus 1.5708 times 0. And that gives us 0.7004. And then we can let n equal 1. T3, we're going to change this number to a 1. Gets substituted here in here. And T at 0.08495 plus 1.5708 times 1. And let's go ahead and calculate that and see what we get. 0.08495 plus 1.5708 equals, and I get 1.65575. And we can let T4 equals and so we got 0.7 and we end up getting 2.2712. And you can see the time progression. If you want to check this, do this minus this, should be the same as this minus this. Solutions 5 and 6, we would just let n be 2, substitute into here, follow order of operations. And okay, that's all for that. It's pretty useful stuff. These general solutions, for some reason, it seems like this is not taught in math, but if you take a physics course, they'll act as if you already know it, and so it's very difficult to figure this out from a physics text, and it's virtually absent from virtually every math text you can find at this level. So, okay, we'll be back with some more trig shortly.